Hello, my name is Alvin Huang, and with me is Ariel West. We are also representing our colleagues Kristen Sarmiento and Professor Vincent Hui. We are from Toronto Metropolitan University, also known as Ryerson University. We're presenting our paper today, Shared Territories, Indigenous Archaeology in Architectural Pedagogy. The past decade has witnessed an incredible ambition by Canadian post-secondary institutions to indigenize their curriculum by drawing connections between curriculum and Indigenous perspectives, traditions, and culture. While the extent of this varies depending upon the discipline, there are often challenges in providing such opportunities within science and engineering faculties in many universities across Canada. From a dearth of Indigenous instructors available across the country's vast expanse to more persuasive attitudinal biases toward traditional Western canon, there are many reasons behind a lack of indigeneity within contemporary STEM-based disciplines, including architecture. In response to this challenge, a multidisciplinary team drawn from a diverse range of disciplines, including architecture, video game design, and archaeology, in order to generate content that presented the commonalities between Indigenous architectural design traditions and contemporary architectural practice. Through an interactive digital simulation of an Indigenous settlement with high-fidelity assets generated from distinguished archaeological researchers and esteemed video game design faculty, architecture students were able to understand the relevance of Indigenous architecture in their own design work, examining the parallels between structure, heat transfer, airflow, moisture control, and programming. This initiative highlights the possibilities of multidisciplinary work towards indigenizing architectural pedagogy. This historical context of the Longhouse 5 project dates a time pre-contact prior to the 17th century in southern Ontario, near the Great Lakes. The Huron-Wendat First Nations occupied areas around the Great Lakes and settled in villages across the province. This site specific to archaeological investigation is the Mantle site in the town of Witchart-Stouffville. Remnants of the ancestral Indigenous village from the Huron-Wendat Nation were uncovered and examined under an archaeological team by Mr. Martin Cooper, Dr. Ronald Williamson, and field direction of Andrew Klisch. In addition, the research was supported by Huron-Wendat Nation representatives Heather Bastian and Luke Lane. In the realm of education, depictions of Indigenous nations often lacked accurate visual aid to historically represent the Indigenous peoples. Most often, the depictions were gestural illustrations, which raised concerns of accuracy of the Indigenous Huron-Wendat peoples. Through the use of digital technologies available today, visual imagery of the Huron-Wendat people can be enhanced to educationally showcase the life of the nation. With the data from the Mantle Site Archaeological Report, the Longhouse project was created to develop an immersive and interactive learning tool on the history, culture, and architecture of the Huron-Wendat Nation in the Mantle Site. Through working with archaeologists, architects, and game developers, the execution of the Longhouse project has produced an open-source interactive simulation of the Mantle Site. The Archaeological Endeavor started in 2003 by the archaeological team in Witchart-Stouffville, where information was gathered to map out the village throughout its many years of use. An example of the data collected, the key plan showcases the entire Mantle Site, and the fragment drawing notes the possible locations of structural posts, fire pit features, earths, and collectively maps the footprints left by the longhouses that existed years ago. Through discussions between the architecture team and archaeologists, educated assumptions of why the Huron-Wendat people built their structures in a certain way can be speculated with behaviors and planning trends we see in contemporary architecture. With the data collected, the game development team, made of individuals from Sheridan College and Toronto Metropolitan University, collaborated in developing a digital model accurate to the site. Using GIS data, height maps, and drawings from the Mantle Site report, the team created the environment using digital tools such as Unreal Engine, Houdini, and Autodesk Maya. With the development of Mantle Site complete as an entire city that one can walk through in digital space, the architecture team has utilized the model as an educational tool by comparing the macro and micro details of the Indigenous Longhouse with macro and micro details found in contemporary buildings. Elements such as heat, air, moisture, structure, programming, and circulation were the details of focus. The detailed recreation of the village offers a simulation for architectural education, where architects and archaeologists can use visualization as a medium for discussion. Subjects from the construction practices to the assemblage of the longhouse structure were discussed and proposed through relation to methods of construction today. The simulation showcases the daily activities on the site, from how the indigenous space would need spaces for drying food and meeting as a group, suggesting that these spaces needed to be planned by the village. In terms of assembly, discussions question how the structure would look like disassembled and how it was assembled during seasonal relocation. And to begin, we will look at the details of heat consideration and usage within the longhouse. In this drawing created from a digital model, it showcases the central axis of the longhouse, where fire pits used for cooking and as a heat source, as it gathers people together within the hearth. The heat sources are placed beyond the vestibule and are placed at the floor of the main living quarters. To accommodate for the heat and smoke buildup within the interior, there are several openings in the longhouse roof, which acts as a passive ventilation system for the smoke to escape. The placement of the fire pit within the center of the structure showcases the notion of radial heat to be considered in optimizing the fire pit within the longhouse. Within the in-game demo, smoke can be seen exiting the exterior openings of the longhouse roof, and on the interior it showcases the placement of the fire pits and the openings directly above, acting as a light and heat source in the center of the longhouse, allowing for gathering to take place around her. Sluice Point by Omar Gandhi, located in Nova Scotia, consists of an open programmable space with flexible elements such as sliding panels and a central rotating fireplace that allows for the center of activity to shift as needed. The wooden millwork contributes to the warmth of the space as well. Similar to the longhouse, the essence of a hearth is still utilized today in contemporary homes as a means of heating the space and as a place of gathering, as a fireplace is located within the living space. The use of drying racks, a common First Nations method of preserving food, near the opening utilizes the flow of heat as a technique to preserve food. The items are hung from the interior structure and follow the horizontal layout of the structural members. Used in coordination to the fire pit heat and smoke, the drying racks were ultimately placed in higher elevation. The in-game demo features an in-depth view of textured models of hunted, harvested food for occupants of the longhouse, and in addition, post placement to the opening within the roof is unobstructed, allowing for smoke to head out of the longhouse. On the micro level, in contemporary architecture, the Daniels Building by NADAA utilizes a highly efficient water-based air conditioning system alongside a rainwater recovery system and green roof as a means of cooling the building. The building therefore embodies many sustainable features that utilize stormwater management strategies, and ventilation is configured to give access to a natural cooling system with vents in the roof designed to be released. The airflow through the longhouse is streamlined by two openings on either ends. In plan, this CFD simulation shows the velocity of wind flowing through the longhouse, and the curvature of the longhouse lessens the lateral wind loads parallel to the entrances with the vestibule, stopping an incremental amount of airflow before the main living quarters, and also preventing wind loads from affecting the occupants inside. Here's another view of the same CFD simulation, but in section. The in-game examples showcase the curved form of the structures contained airflow within the longhouse. Gaps in the roof of the longhouse lie above the fire pits to provide adequate smoke ventilation. The doors at both ends of the longhouse alongside the roof gaps create a cross-ventilation system to ensure that air is being circulated throughout the structure. The 60 Richmond Street East Housing Co-op by Tipo Architects also creates a passive ventilation system, in which fresh air is constantly flowing through the vertical chimney located in the core of the building. Her structures provide resistance against wind and other lateral forces, and therefore the curvature and layering of the bark creates an envelope that holds a certain amount of resistance against air infiltration from the outdoor elements. This keeps heat contained inside with an intention to control a level of comfort within the main living quarters. In game, the texture can be seen closely, and especially with the layering of the shingles. As we know today, the layering of the bark in section can be seen in the doorways of the main longhouse entrances. The Center for Cellular Biomolecule Research by Benish and Architects Alliance utilizes a double-skin facade system to employ natural ventilation that acts as a chimney to circulate air. The operable windows are located on the interior skin of the facade, while operable vents help ventilate on the outer skin, allowing for natural air circulation.
The convex shape of the longhouse, like a pitched roof, allows for water and snow to run off the structure. This way, the geometry of the roof prevents water from seeping through and leaking into the longhouse. In-game, this cladding is shown through textured bark held within an envelope cage. Looking at a similar example, the Snowboarder's Cabin by Scott & Scott uses a locally harvested red cedar cladding on top of an A-frame structure, which allows the building to shed snow and water effectively. Both projects take advantage of the same water shedding principles. Water infiltration is mitigated through the overlapping condition of the bottom and top layers of the envelope. Bark is first layered on the bottom and then built upwards in order to overlap itself. This technique takes advantage of gravity in order to deter water. This in-game example shows the overlapping layers of bark from both the inside and outside of the longhouse. Because of the layering, little room is left for light or air to infiltrate the longhouse. Looking at the Odato Indigenous Center by Gow Hastings Architects, we can see the same overlapping techniques being used in order to prevent water from damaging the exterior envelope. This campus building at Seneca College is a gathering space for First Nation, Métis, and Inuit students, and its convex shape is inspired by the Haudenosaunee Longhouse. While the curved external structure of the longhouse only works to support itself, the internal structure supports a majority of forces exerted onto the longhouse by its occupants. The contemporary office building works in a similar fashion, with its occupants being structurally supported by an internal core and its facade working to separately support itself through a curtain wall and mullion system. The structure of the longhouse is displayed in-game through a series of adjacent structures. The initial structure is displayed first, then the self-supporting envelope system followed by the bark enclosure. The final secondary structure layer is then added in order to operationally maintain the longhouse throughout its life. The same construction principle is also shown in contemporary buildings today. The Toronto Dominion Centre by Mies van der Rohe is constructed using an internal grid that supports the primary structural elements of the building, like floors. An internal curtain wall system, which supports itself, encloses the building on its exterior. The internal structure uses a lashing technique in order to hold structural members together. The lashing also acts as a flexible joint, which gives way for the longhouse to deform over time, without cracking due to the surrounding changes in temperature. As seen in game, lashing connections can be examined at an eye level in order to understand how the structural members are coming together. This method is also seen in contemporary projects such as 222 Jarvis by Max Miller. In this project, the gasket strips, control joints, and soft joints allow for the building to weather and deform over time without the cracking of materials. Looking at it from a programmatic point of view, the layout of the longhouse is also similar to that of contemporary buildings. The longhouse has a vestibule located at each entrance with the main living spaces further beyond them. This linear layout allows for a progression of spaces which utilize storage and utility before continuing to residential spaces. As seen in game, the player walks through the interior condition, showcasing the placement of goods, foods, utility items, and residential areas within the longhouse. The same principle is also true in the contemporary home, which sees a mudroom or vestibule at the entrance where occupants may remove belongings before entering living spaces such as the kitchen or bedroom. Looking at a contemporary tower, this principle is still true at a larger scale. With a modern condominium tower in Canada, the program of the building is laid out vertically, with public and private spaces being separated. The lower podium holds the functions like gyms and amenities, while the upper portion of the tower holds residential functions. Another programmatic element is the organization of firewood beneath the lower beds in order to dry the hanging goods above. This layout shows an understanding of programmatic organization with correlation to the mechanical function of the longhouse. As shown in game, a detailed layout of material goods is rendered according to its purpose in the longhouse. This presence of sequencing also occurs in contemporary malls such as the Eaton Center by Zeidler. Progressive programming from interior to exterior crosses through vestibules and corridors to end up in the individual stores.